Human progress is hardly conceivable without the services rendered by chemicals. Chemicals such as pharmaceuticals, oil and plastics are vital to our daily lives. Over 100,000 different chemicals are registered at the European Chemicals Agency alone. Chemicals often enter the environment, whether intentionally or unintentionally, and pollute natural and human habitats, even in minute concentrations. Researchers at the Helmholtz Center for Environmental Research, UFZ, have joined forces in the integrated project Controlling Chemicals' Fate. They are developing systematic approaches to the behavior of chemicals in the environment and are linking knowledge about the structure of chemicals to their degradability in natural and technical systems. The high quantities of chemicals and their diversity require a deeper understanding of their biodegradability in the environment. At the UFZ, we are researching the potential of natural and technical systems to eliminate unwanted chemicals or render them harmless. The Langenreichenbach experimental station is not far from Leipzig. Nature-based sewage plants are developed here. The objective is to minimize the incursion of contaminated water and therefore chemicals into the environment. Some of the plants developed here are already being deployed in various areas of the world. Some chemicals are not fully transformed into harmless products in nature. In cooperation with ecotoxicologists from the UFZ, we are examining the extent to which treated wastewater still has a harmful impact on organisms and ecosystems. Our investigations deal with micropollutants that enter wastewater through medicines, for example. Our objective is to identify these substances and prevent them from being discharged into nature. Alongside such nature-based solutions, the researchers at UFZ are also searching for chemical and technical means to completely destroy substances that are difficult to degrade. Examples of this include perfluorinated compounds, which are used in waterproofing sprays, outdoor clothing, or fire-extinguishing agents. Research in this field is still in its early stages, but the first successes have become apparent. In laboratory experiments, the researchers have, for example, identified a simple method of degrading these extremely stable chemical substances with the help of iron and sunlight. Despite all efforts made, it was and remains impossible to completely prevent chemicals from entering the environment. In some cases, such as pesticides, they are intentionally spread. The fate of chemicals in the environment is still largely unknown, however. The main issue is identifying the capacity of an ecosystem to degrade chemical substances. What are the conditions under which degradation takes place? How long do certain substances remain in ecosystems? Does degradation take place, or is it a transformation? And how can we promote such degradation? The integrated project has gained important insights in this respect over recent years. One research group, for example, is tracing the mechanisms involved in the interaction between bacteria and fungi in the degradation of pollutants in the soil. There are about as many bacteria in this crumb of earth as there are people living on our planet. They live in complex communities and rely on transport processes for their survival. As an example, many bacteria move along fungal hyphae and their ramified networks. In this way, they can make a decisive contribution to the degradation of chemicals in nature. The researchers compare such hyphal networks of fungi with highways. In addition to microorganisms, water, nutrients and pollutants are transported along this network. In this way, the bacteria come into contact with the pollutants. This is the only way in which any degradation at all can take place. A special mass spectroscopy method performed at the in-house Center for Chemical Microscopy, PROVIS, make it possible to observe the processes taking place between fungi and bacteria, even at nanometer level. The work by the researchers extends far beyond mere laboratory experiments. The findings about the fungal highways are transferred to mathematical models. This makes them easier to understand and facilitates the development of recommendations for the management of ecosystems. We UFZ researchers provide impetus and make findings available that include the entire life cycle of a chemical as part of integrated environmental protection. After all, we will remain dependent on the services they provide for a long time to come. Our work as part of the Controlling Chemicals Fate project ultimately contributes to more environmentally sound substances and sustainable use of chemicals.